Hi, and welcome to my C++ course. I've already released this course in individual videos, but I've decided to make it into one long 2.5 hour plus video. I hope you enjoy. Please subscribe to my channel as I will be releasing new videos in the future. It's the best way you can support my channel, and it's the best way for you, the viewers, to get new content. I hope you enjoy my course. Thank you. Hi. Welcome to my tutorial on creating a HelloWorld program in C++. Today I will be using the NetBeans Integrated Development Environment to create a program in C++. You can use any integrated development environment for this. The NetBeans Integrated Development Environment is free, so I'll be using that. Other popular ones are Visual Studio, Code Blocks, and more. But let's get to the meat of the HelloWorld program. To write a HelloWorld program in C++, you start with #include IOStream. This is a preprocessor defined constant which includes input and output information for the processor and for your C++ program to function. Next, you're going to want to include the namespace standard. Prevents you from having to type std : throughout the entire program constantly. I'll show you what I mean later. Next, we're going to type the main function. This is how you type the main function. You can either leave your open and closed brackets like this or like this. It's merely a preference. Each main function ends with a return 0. This means you're ending the program. The main function is of a return type integer. It returns an integer. You are returning 0 to the main function, an integer, meaning you're returning a value of 0 and ending the program. Now, if we did not have the using namespace std, we would have to do something like this. However, since we have the namespace already, we do not need this std : throughout the program every time we do a cout state. So this is a complete, concise C++ HelloWorld program. I hope you've learned something. Thank you for watching. Okay, welcome to another educational video on computer science. I'm Sean, and we've got a real loopy video for you this time. Sorry, I was told I needed to add a little humor to my videos so I could be more engaging. But today we're going to be talking about for loops. For loops can help you in many different ways to construct many different things, but today we'll be outputting the numbers 1 through 100 successively on a line to give you an idea what a for loop can do. What I have here is the basic shell outline of a C++ program. Everything goes inside the main function. If you haven't seen my Hello World video, you need to go watch that. So if you haven't seen my Hello World video, please pause this video and go watch that one. But everything goes inside the main function. So this program will be very simple. All it is going to be is basic for loop. So for create an integer variable I, set it equal to 0. While I is less than 101, increment I by 1. Sorry, there should be 2 pluses there. That means I++ is code for I plus equals 1, or I equals I plus 1. What I'm going to do here is do a cout statement, which you would have learned about in the Hello World video. I'm going to simply output I each time. Now you're going to learn about indel statements. Indel will simply skip a line. This will hopefully do. Sorry, this should be 1 here, everybody. If my math is off, we'll find out. But this should output 1 through 100. If I'm wrong, we'll find out. But this should output 1 through 100. Let's go ahead and run the program. Okay, as you can see, 1, math was correct, 1 through 100. What happens here, I'll explain a little more, is it starts out, it initializes this I variable, and this could be anything. We'll call it num. It's just a number. We usually say I, which is a convention in computer science. But they also use num sometimes. Not num like you're at the dentist and you're num. It's num as in number, you know. But anyway, but I'm just, you know, this is starting with 1. And we go here, we check. Is it less than 101? Yes. So we go here. We do this. Then we go here. Add it to 1. Then we go here. 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 Once this fails, we stop. And we go here. Do, and program. So I hope you've learned something from this video. And if you have any questions, feel free to comment, like, subscribe, etc. Thank you for watching. Hello, welcome to another video. This video will be about while loops, which are very similar to for loops. In fact, you can do anything with a while loop that you can do with a for loop and vice versa. So what I'll do is I'll output 1 through 100 successively on a line using a while loop. What I'm going to do is create an integer, int I, set it equal to 0, and say while I, I did it again. We're going to set I equal to 1. While I less than 101, that up. While I less than 101, bracket, enter. I is less than 101, simply output I in line. If you haven't watched my previous videos on for loops I had my Hello World video. You need to go watch those because you'll have a much better understanding of this video. But what's going on here is first I'm creating an integer variable. I should have created a video on variables, which I should do next. And that will probably clear things up. But what this is it creates a space in memory to store numbers, or data actually, and it's storing the number 1 here. It says while I is less than 101, do everything between these two brackets. So it goes here, the output's 1, and then it says, oh, actually, forgot to do one thing. I plus. We need to increment I every time. So it goes 1, then it adds 1 to I. Now I is 2. Then it outputs 2. Now I is 3. Then it outputs 3. Now I is 4. Then it outputs 4. Eventually I equals 101. This fails, and we go here. Once we're here, program ends. Once the program ends, it should say run successful. Let's try it. As you can see, 1 through 100. Run successful. Thank you for watching. Hello, welcome to another educational computer science video. I'm Sean, and today we'll be talking about if-else statements. To make this video short and sweet, I've already typed out the if-else statement. If you want to type this out yourself, you can pause the video and type all this out. It's very simple to do. But what I did was I made a video already and I basically messed up, so I had to redo the video, and it's this video. And here's this video. So what an if-else statement is, it's a conditional statement where what I've done here is I've created a variable, integer I set to 4. What an if-else statement is, it's an if otherwise statement. So if I equals to 1, we're going to do this. Otherwise, if I equals to 2, we're going to do this. Otherwise, if I equals to 3, we're going to do this. Otherwise, if I equals to 4, we're going to do this. Otherwise, if I is anything else, we're going to do this. Say it's something else. So, what do you think will happen here? Obviously, it's going to say otherwise I equals to 4, and it's going to say it's 4. So, let's run the program and see that it's 4 is outputted as we expected. Now, if we input 100, what do we expect? We expect it to say, that's correct, you got it. It's going to say it's something else because it's not 1, 2, 3, or 4. It's otherwise, it's something else. I like to say otherwise because it's better than saying else to me. You know, I think they just said else if to be lazy. You know, it should be otherwise. But anyway, that's how I understood it when I was learning. So I hope this helped you understand if-else statements better. Thank you for watching. Hello and welcome to another educational computer science video. Today we're going to be talking about Booleans. Booleans are a very simple data type in that they can only store 2 values, true or false. In order to understand this example, you're going to have to watch my video about if-else statements. So if you haven't seen my video about if-else statements, pause this video now and go watch the video about if-else statements. But you could probably still understand Boolean values otherwise because they're very simple. They simply store either true or false. So what I've done here is I've created a variable called I that stores the value true. I've created a conditional if-else statement where if I is equal to true, it outputs the statement it is true or it's true. Otherwise, if I is false, if the Boolean value I is false, it outputs the string it's false. Then it ends the program. So in this example, it should output the statement it's true. Let's see what happens. As you can see, it says it's true. Now let's change it to false. F-A-L-S-E, false. Now it should output the statement it's false. It's false. This is a very simple example of Boolean statements. I hope this helped you understand Booleans a little better. Thank you for watching. Hello, welcome to another educational video on computer science. I'm Sean, and this video will be about comparison operators. There are, let's see, 6 main comparison operators, as you can see here. There is the equal sign, the exclamation point equal sign, the greater than symbol, the less than symbol, the greater than equal sign symbol, and the less than equal sign symbol. What these represent are equals to, like you learned in mathematics, does not equal to, greater than, less than, greater than or equal to, and less than or equal to. I'll demonstrate this by using a simple if-else statement. If you haven't learned about if-else statements, go back to my video about simple if-else statements. So, well, let's start by creating 2 Boolean values. Bool I equals true, bool j equals false. Actually, we don't need to do this. Sorry. We can just use true or false. So, let's say if one is less than if 1 equals to 1, output they're equal. Actually, we're not going to do an if-else statement. We're just going to use if statements in this example. I can't think of any jokes for this video. I was told to be more engaging and use jokes, but you can humor me in the comments. Okay, so this obviously will say they're equal. Indel simply skips to the next line. If 1 is not equal to 2, that's true. We want to output they're not equal. ahead and be lazy with the copy and pasting here. Now, let's use the greater than symbol. If 3 is greater than 2, let's say it's greater. In the example here, we use the less than symbol in an example we're familiar with. Sorry, 2 is less than 3. Getting a red squiggly line here because I accidentally ran the program before I wanted to. But let's put it's less. Now, we can do for greater than or equal to, obviously we can do 2 examples, but I'm just going to do 1. So we can use the same thing, 3. 3 is greater than or equal to 2. It's greater than or equal to. Finally, if we use 1 here and we do a less than symbol, it's less than equal to. Now, given that all these statements are true, 1 is equal to 1, that's true. 1 does not equal 2, that's true. 3 is greater than 2, that's true. 2 is less than 3, that's true. 3 is greater or equal to 2, that's true. And 1 is less than or equal to 2 is also true. All these should execute. So let's see what happens. We should get they're equal, they're not equal, it's greater, it's less than, it's greater than or equal to, it's less than or equal to. All on separate lines. Let's run the program. As you can see, they're equal, they're not equal, it's greater, it's less, it's greater than or equal to, it's less than or equal to. I hope this helped you understand conditional, comparing values better, comparison operators better in C++. Thank you for watching. Hello, and welcome to another educational video on computer science. I'm Sean, and this video will be about arithmetic operators. The arithmetic operators are plus, minus, times, the star symbol, which is times, divide, which is the /, modulus, which may be new to you, and it is the percent sign, the double plus, and the double minus, which we'll learn about in this video. I actually taught you about those in previous videos. For example, in the for loop video, I taught you what the plus operator did. The minus is very similar, and we'll learn about it shortly. So we're going to create 3 variables for this video. Int I is equal to 5, integer j, set it equal 4, and integer k, set it equal, I can set it to anything. Okay. Now, let's say we see out I plus j. Anything will happen. Obviously, 5 plus 4 equals 9. As you can see, 9 is outputted. Now let's try the minus. What do you think will be outputted? 5 minus 4 equals 1. 1 is outputted. Let's try multiply. If we use the multiply symbol, 20 will be outputted. 20 is outputted. Now here's a different one. You would think if we use the divide operator, we would get a decimal. However, we're going to get something else. That's because it uses integer division in computer science. It's not regular division, it's integer division. 1. That means that j goes into I one time and one time only. But really, it's 1 point something. So, it's not regular division, it's integer division. Now, for the modulus operator, the modulus operator gives us the remainder of dividing 5 by 4. Should be 1. 5 divided by 4 gives us a remainder of 1. This is useful for finding even or odd numbers, which you'll learn about later. If someone says, tell me if this number is even or odd, you could say, well, modulus 2, is it 0? Or modulus 2, is it 1? If it's modulus 2, 0, then it's even. If it's modulus 1, it's odd. So that's where the modulus comes in real handy. Now let's use the plus plus operator. Plus. So increment 5 by 1, giving us 6. Whoops. Actually, I is incremented after the cout statement, so it gives us 5. If we want to increment 5 before the cout happens, we have to do this. Plus plus 5. So let's try that. 6. To give you a better understanding, since we usually use I plus plus, not plus plus I, I'm going to do this. I plus plus, and then I'm going to output I. That should give us 6. Now, what will I minus minus give us? That's 5 up here. What will I minus minus give us? I minus minus will give us 4. That's correct. Hopefully this helped you learn the arithmetic operators in C++. Thank you for watching. Have a good day. Hello, welcome to another educational video on computer science. My name is Sean, and this video will be about data types. There are 6 different data types. The ones we've been dealing with so far are the integer and the Boolean, but we have not seen the other 4, so I'll go over those. The integer is anything from negative infinity to positive infinity that is a whole number, such as negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, but it isn't something such as 1.1 or negative 1.1. So it's a whole number. Character can be anything that is a character in the ASCII alphabet. It could be A, capital A, lowercase a, but it has to be just one single character, not multiple characters. The floating point number is a decimal, and it can be correct up to 6 decimal places. As you can see, I have put 6 decimals here to represent that. The double, which is used much more often than the float, is correct up to 10 decimal places. And as I said, it's used much more often. So if you're going to be dealing with decimals, use the double. The Boolean is either true or false. And finally, the string is a series of characters, such as hello. Now, to use the string, we're going to have to go to the very top here under include IOStream, and we're going to have to include string for this to work. Now let's run the program and see if it's successful. Yes, run successful. Okay, I hope you learned something in this video. I hope you learned about data types and what they are in C++. Thank you for watching. In the next video, we'll be talking about library classes. Since we learned about the string library, and we've learned about IOStream, we'll learn about a few others in the next video. Hello, welcome to another educational video on computer science. Today we'll be talking about library classes. There are many different library classes you can use. So far we've looked at IOStream and string. Today we're going to be learning about several more. And because I don't want to be charged with plagiarism, I have used C++ Programming in Easy Steps by Mike McGraw as a source for part of this. Now, but some of this I also learned on my own, so not all of this is from the book. IOStream is for basic input and output to the screen. Pound includes string. String is for using strings. Okay, now we're going to learn about pound include fstring. This is for file I/O, or reading and writing to a file, which we'll have a future video. Next, I learned about in the book is string, which you can use to, quote, convert strings to other data types. I personally haven't used that one, but I'm sure it's very handy. Now, I'm going to include vector, which is similar, which is a container of sorts that will have a future video. You need to include vector library to use vectors. The vector data structure. Next, we have which is also from C++ and Easy Steps. I'll include, I would actually recommend getting that book. Standard accept, which, quote, reports logic errors and runtime errors, according to them. And this is one you will use. Don't include ctime. You use this for random number generation. Random number generation is very useful. Say you want to make a dice game, or you want to make a randomly generated statistic. You want to randomly pick something. You use the time as your random number catalyst. Okay, here's some not mentioned in the book I use, and we'll be using later when we learn about the STL in a future video. It's called stack. It's a data structure, and it can be used for sorting and many other things, creating other data structures. Another data structure, queue. We'll learn about stacks and queues in future videos once we learn about the STL. I hope you learned something from this video, but from now on, this will be the basic outline of our C++ program, this whole thing, rather than the simple IO stream using namespace std. I'll include all these libraries, and actually let's see if the program runs with all these libraries just to see. Yep, there's no problem there. All these libraries are included and the program works fine. So hope you learned something from this video, and see you in future videos. Thank you. Hello and welcome to another educational video on computer science. This video will be about inputting and outputting strings. This is another video I probably should have done earlier in the series, but it's very important. So we've seen that we can output a string by doing cout, something like hello world. Go ahead and run that. As you can see, it will say hello world. But what if we want the user to type something? Well, that's where we use something called the cin. Okay, so let's create a string and call it my string. My string. Let's tell the user Input your message. Input your message. And we will see in greater than sign my string. This will prompt the user to enter in a string. This can also be used with integers, can be used with characters, can be used with all different data types, but I'm just using strings in this example. We're learning about the CN and COut, basic input and output in this video. So, after this, we're going to output you typed my string. Okay, let's see what happens when we run this program. Input your message. Okay. You typed okay. As you can see, well, this is basic input and output. Let's try an integer value this time. Int my, let's call it my int. My int. Name it so it makes sense to us. Let's say input your number. So this makes sense. Input your number, 100, 1000, how about? Okay, type 1000. This can be used for doubles, anything else. Now you've learned about basic input and output. Thank you for watching. Hope you learned something. Hello and welcome to another educational video on computer science. Today we'll be talking about arrays. Not array like a laser array or array like a fin ray, but array like a data structure array in computer science. The array is a data structure. You can think of it as like a set of boxes next to each other. And that's kind of what the computer science books like to illustrate it as. It's a bunch of boxes like together next to each other in memory. You can store values. Store values such as numbers, strings, decimals, anything you want next to each other. And so you can think about it in that way. That isn't the syntax for an array. That was just an illustration to get you to understand what they look like in your mind. But they're used to store multiple items of data. An array can be declared like this. Int my array to size 10. we just made an array of size 10. It's 10 boxes next to each other. Now, the thing about arrays is you don't count them from 1 to 10, you count them from 0 to 9. In base 10, you count from 0 to 9. So, anyway, that's how you do it. So, there's more than one way to initialize an array. You can initialize it like this. 0, 1, 2, 3, 4, 5. It doesn't have to be in order. It could be anything. 103, 545, 345, example. 7, 8, 9, 10. Actually, 10 numbers right there. And make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've stored 10 numbers in this array. Now, let's go ahead and print these numbers out using what we learned about earlier, the for loop. I equals 0, I less than 10. That means let's do something 10 times. Okay? This is how we output the array. Cout my array sub I. I'm going to go from 0 to 9. Remember, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 fails, and then it goes to here. Okay? So, we should get 0, 1, 2, 3, 4, 5, 45, 7, 8, 9. As you can see, we got 1, 2, 3, 4, 5, 345, 7, 8, 9. Now, this is not how we usually fill an array. Initialize an array. Another way we can do it is with 10 cin statements. Cin my array 0. And do that all the way through 10. Or 0 through 9, as we said. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see, we inputted 1 through 10 and then outputted 1 through 10. Another way we can initialize this is by using a for loop. simply assigning values to it. Saying my array sub I equals I, for example. Now, the array should be 0 through 9 when it's output. Let's run the program. It should output 0 through 9. Yes. 0, 1, 2, 3, 4, 5, 6, 7, 8. So, hopefully you understand what arrays are now, how to initialize them, how to use for loops to initialize them, how to use cin to initialize them, how to use brackets to initialize them, how to output them, and so forth. Hopefully you've learned something from this video. If you didn't learn anything, please rewatch the video. Arrays were kind of a sticking point for me when I was learning computer science at the very beginning. I did not understand them, but you just have to, watch the video again, and you might get it. So I think you'll get it if you just really try. So, but if you did get it the first time, congratulations, and thanks for watching. Hello, and welcome to another educational video on computer science. Today we're going to be learning about two-dimensional arrays. Two-dimensional arrays are slightly more complicated, but they're very easy once you learn them. To create a two-dimensional array, such as you can think of a two-dimensional array like this. Here we have a 2 by 3 two-dimensional array. This one has 2 rows and 3 columns. So it's 6 boxes total with 2 rows, 3 columns. So how do we create something like that? Well, we go int my array 2, 3. To initialize it, do something like this. 0, 1, 2. That is the first row. Okay, so there's one row. Now we can create the second row. Sorry, I keep using the wrong thing. 4, 5, 6. Spacing doesn't matter in C++, by the way. White space, for the most part, is ignored. So, I have this spaced out, I have this not spaced out. Doesn't actually matter, but to neaten it up, I'm gonna go ahead and make it look the same. Okay, there we go. That will create an array that looks like this in memory. Sorry if my illustrations are kind of corny, but this is what it will look like. 0, 1, 2, 4, 5, 6. Okay. To output the array, we can use a for loop. For. Actually, I'll learn about double E nested for loops in this video. For I equals 0, I less than number of columns, number of rows, I plus plus. And we're going to do this. Let's go ahead and use brackets. Or int j equals 0, j less than number of columns 3, j plus CL my array I j end line. It should output 0, 1, 2, 4, 5, 6. Let's see what happens. 0, 1, 2, 4, 5, 6. Now, we can also initialize an array this way. So we have an empty array now. Let's create the array that way. My array sub I sub j, sub j equals, let's say, create another variable up here called num, set it equal to 0, num. Here we're going to do num plus plus. Now, we've initialized the array with 0 through 5, I believe, if I'm not mistaken. 0, 1, 2, 3, 4, 5. The output 0 through 5. Simply copy paste, same thing, and see out my array I j in line. This should output 0, 1, 2, 3, 4, 5. Let's see what happens. Zero, 1, 2, 3, 4, 5. Okay. Hopefully you understood this video. If you didn't, watch it again. And watch it maybe at half speed. If you did understand it, congratulations. And we'll move on to the next video. Thank you for watching. Hello. Welcome to another educational video. Today we're going to be talking about a very important topic, functions. Functions are used when you want to do something repeatedly, but you don't want to keep doing it over and over again, such as when you're calculating something. You wouldn't want to, for example, keep saying If you wanted to calculate the perimeter of a rectangle, you would want to keep saying, okay, int p, so have p, int l, int. We wouldn't want to keep saying p equals 2 times L plus W every time. Imagine a very complicated calculation such as the quadratic formula or calculating the square root of a much more complicated formula. You wouldn't want to have to type that out. It would be many, many lines long, very many, this many lines long. And you wouldn't want to do it over and over. You'd want to have one function to do it. So you could have one little line to do it multiple times. So that's what functions are for. To create a function, we go up to the top. First we create the function prototype. So for this one, it's going to return let's say it's going to return a double. And it's called perimeter. Just call it per for short. Per rect. Perimeter of a rectangle. Okay. And it's, sorry, the word is skipping my mind at the moment. It has a return type and it has parameters. That's the word I'm looking for. The parameters are length. You can name them anything. You want to be relevant to the situation. So length and width. Semicolon. Don't need this anymore. Okay. Now we simply copy paste this, put it at the bottom, under the main function, delete the semicolon, a bracket, and create our function here. Let's create a number, int num equals 2 times length plus width. Turn num. Now, anytime we want to calculate the perimeter of the rectangle, let's initialize the perimeter to 0. Say, okay, the length is 5, width is 7. Perimeter of this rectangle is, put it in. Let's put in L and W. We put in the two variables, L and W, length and width. We can do this. That's bad. We're just going to do it 100 times. later on. We don't have to keep doing this. We can just do it over and over and over. So now hopefully you understand the usefulness of functions. But to prove to you that it's working, let's output. Instead of putting it here, let's output it here. It should be, let's see, 2 times 12, so it should be 24. Let's see if we get 24. As you can see, we got 24. Okay, hope you understood the usefulness of functions, and hopefully you understand now how to create a basic function in C++. Hope you enjoyed this video. Thank you for watching. Hello, welcome to another topic. Today we're going to be talking about switch statements. Switch statements are not often used these days because you can do anything you can do with a switch statement, you can also do with an if-else statement. So, you know, it's often gone over in class or in a course just because it exists in the language, but most people prefer to use if-else statements. But just for the sake of completeness, I'm going to teach you about switch statements. And I've already written it out, so here it is. I created a variable called score, and you put the parameter in score to the switch statement, and there are certain cases. Okay, so the case in the case of it being 10, okay, that's bad, and you break, and that when you break, that goes to the end, and it will say score is score. I should probably put a space here. But anyway, it basically, oh no, there's an inline up there, so the space wasn't necessary. But we'll see what happens. So this should say bad, score is 10. Okay. We change it to 20. Okay, score is 20. 30. Good, score is 30. Great, score is 40. Amazing, score is 50. Now if we put something invalid here, like say 1, which is not a case, it can only be 10, 20, 30, 40, or 50, then you'll go to the default, which is no score. No score. Score is 1. So this could be done as an if-else statement, and it's a switch statement, and hopefully now you understand what switch statements do, and hopefully you understand that break makes you go to the end of the line here at the end of the switch. Okay, thank you for watching. Hello, welcome to an educational video on computer science. Today we're going to be learning about logical operators, which is and, or, and not, which is the and, the or, and the exclamation point. So, what we can do is create an if-else statement. Let's say we create an I, and j. We say, actually, let's make these Booleans. Sorry about that. Set it equal to true, and set this equal to false. If I and j, see out, well, let's make them both true. They're both true. The only way that this can execute is if both of them are true. That means and. So if I is true and j is true, they are both true. So we'll run this program, and it should say they're both true. Now, if we do the or statement, one could be false. At least one is true. This should output at least one is true. Not sure why it's giving me a squiggly line there, but it should say at least one is true, because in the or statement, either I or j must be true. So let's run the program. At least one is true. Now, the not statement simply negates something. So let's make them both false. Make them both false, and let's say now I or j equals false. So let's make it true. Not false equals true. Not false is the same as true. Let's run the program. Not false is the same as true. So now you understand the logical operators in C++. Thank you for watching. Hello, welcome to another video. Today we'll be talking about structs. Structs are similar to something called classes, which we'll be learning about. And the whole point of structs is to learn about the concept of object-oriented programming, which is what C++ is all about. Object-oriented programming. Well, what's an object? An object is a concept such as a person or a rectangle, a cube, a employee, a pet, anything you can think of that can be conceptualized and used in C++. So let's do a person in this example. Let's do struct person. The struct has what's known as members and methods, just like a class. A member is such as an int, a char, a string, a double. A method would be a function of the person, such as the person walks or the person calculates. So we're going to say this person has an age. I'm going to say the person has a height. Structs are public. The members of a struct are public by default, while the members of a class are private by default. You can specify, and we'll learn about public and private more when I go over classes in a future video. But this is how you create an object with a struct. So let's go into main and say person Joe dot age equals 21. Let's give him, first we have to say person Joe. Let's also create a person named Bob. Joe's age is 21. And person Joe height equals, we'll say that this is in inches, we'll say 60. Okay. Now, let's do Bob. Person Bob age. As you can see, when you use the dot notation, the integrated development environment automatically gives you a choice of either age or height because it's very smart and knows that you want to choose either age or height. So we're going to make Bob older than Joe, and we're going to make him taller as well. So let's make person Bob dot height. So he gives you a choice because it's acquainted with object-oriented programming. Equal 65. Well, let's do an if statement. Let's say if Joe dot age less than Bob dot age, output Bob is older than Joe. Otherwise, oops, forgot a semicolon here. Very common in C++ programming, forgetting the semicolon, but here we go. Otherwise, Joe is older than Bob. What's going to happen in this case? Well, we know that Bob is older than Joe, so this is the one that's going to happen. But when you have data that's coming from a file, for example, you may not know in advance. So we're going to learn about file I/O in a future video. In fact, that's the next video. Now let's copy and paste this. Say if Joe.height less than Bob.height, Bob is taller than Joe. Otherwise, Joe is taller than Bob. Now, given this information here, our Ifelse statement should say, let's put inlines at the end of all these. Inline. This should say Bob is older than Joe, and it should say Bob is taller than Joe as well. Let's see what happens when we run this program. Whoops. Okay. Oh, actually, we don't need person here. Apologize for that. Now we can simply run the program and see that since we already initialized person Joe, we didn't need person in front of these. We just say Joe.age equals 21, Joe.height equals 60, Joe.age equals 23, Joe.height equals 65. It's good that happened because you can see that when you have an error in your program, you simply click on the link. It shows you where the error is, and you can fix it. So there you go. Bob is older than Joe and Bob is taller than Joe. I hope you've learned something from this video, and thank you for watching. Hello, and welcome to another video on computer science. Welcome to the File I/O portion of this course. File I/O is very interesting because you can input and output data to a file. You can get data from a file, or you can output data to a file. Now first, what we want to do is we want to find the location of this file here. So let's go in Windows. I'm going to go to this PC. So let's go to this PC. Local disk, users, usually it's your name, OneDrive, documents, NetBeans project, and refine the C++ application. Now here we find the main file. In File I/O, if you don't specify the file location, the file will be created in the same location as the main file. So we can create a new text file. Let's call it this file. Look at the properties of it. It's a .txt file. Okay. We're going to open this file. Let's put some data in there. Let's put 1 and 2, 3, 4, 5. Okay. Save it and close the file. We're going to read that data later and maybe store it in an array or something. We can also create a file. So that's actually what we'll do first. We're going to create a file. So let's do that. In order to use in File I/O, you have to include fstring. That's what that's for. So anyway, getting started here, we'll want to do OF string my file a new file created text. Creates a whole new file. Now we have to see if the file is open. If my file dot is open, close parentheses, do my file stuff in the file. This dash n, backslash n, that means new line. Okay. So we're putting stuff in the file. We just created a new file and we put stuff in the file. So else output. And when you have an else there, you don't need the open and close brackets, by the way, for the final else. Else file could not open. Sometimes a file can't open for some reason. Maybe there's a problem with your system or whatever. We'll see if that happens to me. Okay, let's run the program. Run successful. Let's go in our file here. A new file created. Stuff in the file. We created a new file and we put stuff in the file. Alright. Now that we learned how to do that, let's learn how to read from a file. To read from a file is different. We don't use OFStream, we use IFStream. I'm going to teach you how to comment out stuff. You can do, instead of deleting that, I'm going to use this. Okay. All right. Now, this will all be ignored now. This will not execute in the file. You can use comments to take notes. You can use comments to do all kinds of stuff. Write out, erase previous code like I just did. Or not erase, but comment out previous code that you don't want anymore if you want to look at it, and so on. So anyway, I have stream. My file. What was the name of the file we created? Uh-oh. Sorry about that. We got to go to NetBeans. This file. So let's do this file. This file. Text. Let's get a string first. String. My string. Now, if my file dot is open, going to do something interesting here. While get line my file comma my string let's create an array up here. We learned about arrays earlier. Int array R1, let's call it 5. Remember we had 5 numbers in there. Okay. Now I think I'm doing this correctly. So my file my string and we may have to create a dummy variable if I remember correctly, but we shall see. You know what? Let's not do this. Let's simply output in the file. So we can just see out what's in the file. My string. That way we can better understand it. So see out my string. And end it with a new line. Next we want to close my file, close, simple, and do an else statement, else CL file couldn't here we go. So now we will output 1, 2, 3, 4, 5. Where does 1, 2, 3, 4, 5 come from? Well, it comes from the file. Remember, we had in this file we had 1, 2, 3, 4, 5. So let's see if that works. One, two, three, four, 5. As you can see, a red input from a file using opening the file, get line, using a string, and outputting a file. I know this is sort of hard to understand. You just have to memorize this. I actually, as a reference, I used C++.com as a guide for this. I don't want to be accused of plagiarism, so I, this is something I had to memorize myself when I was learning, but I actually had to jog my memory myself for the exact syntax on this. But if you go to Google and type in file.io C++.com, that's C with CPLUS.com, has a great example that's almost exactly like this that you can use with file.io. And they also have more information for checking state flags as well as get input string positioning, other things. But this is the main thing. You need to understand how to read from a file and how to write to a file. Okay, thank you for watching. Hello, and welcome to another computer science video. And in this video, we'll be learning about pointers. Pointers are kind of a difficult concept because we're not just dealing with numbers and characters and strings anymore. Now we're dealing with actual addresses in memory. What a pointer does is it points to an address in memory. So if we have, say, an integer and a equal to 15, for example, how do we get what happens is it sets a block in memory 15, and it also has 15 in it, and it also has a hexadecimal number, some hexadecimal number, and again, OX or something like that, attached to it. So, how do we get that address? Well, you use something called the address of operator, and it's simply the ampersand sign. Address of A. So if we run this program now, it will give us the address of A. The address of A is this: 0x5FAAC. I'm sorry, the OX goes before. So it's a hexadecimal number, which is different from the regular numbers you're used to, 1 through 10, whatever. But it's a number like any other. It's a number in memory, and that's how you get the address of a variable. To create a pointer, however, we use int. Some people like to do this. Let's say a pointer. I like to do int pointer like that because it specifies it's an int pointer. Anyway, that helps me remember that it's an int pointer. So int pointer A equals to, it has to be assigned to an address. So int pointer equals address of A. Now, when we output this a pointer, this points to the address of A. So we're going to get the same thing that we got earlier. Should be two of the same numbers As you can see, it's the same address. Okay, so in pointer A points to A. Now how do we get 15 out of this if we want to reference or dereference it? Well, all you do is you dereference a pointer. In this case, you're not creating a pointer, you're using the star as a dereferencing operator. Star has two functions. It creates pointers over here, and it dereferences pointers over here. So this should give us 15. Okay. This is the very basics of pointers. There's lots you can do with pointers, but if you understand this, you understand the very basics of pointers. And now we can learn about something I think is more fun, which is pass by reference and pass by value. What's the difference of that? And that's a continuation of what we learned about in functions. And that's what we'll learn about in the next video. So stay tuned. Thanks for watching. Hello, welcome to another video. Today we're going to be talking, in this video we're going to be talking about pass by reference versus pass by value. This is related to pointers in that we use the address of operator. In a way it's not related, but it deals with functions. So we're going to create two functions here. Int, returns an int. Or, let's make it void. Void, you haven't been introduced to that yet. Void means it returns nothing. Void add 5. Add 5. And input, or the parameters will be void add 5. Parameter will be ampersand. Actually, let's call this something else. Let's call this val, and call this ref. This will be a function that passes by value, and this will be a function that passes by reference. You've already seen functions that pass by value. Now, let's take these two, copy, paste. And num equals num plus 5. Return num. Actually, this will be an int. We're going to make this one an int, and the other one a void. Let's see right in a second. Okay. This one could be void because num equals num plus 5. Okay. Now, we have a number. Let's say int a equals 15. And we add cout add 5 val. Inputting a. Now that should give us the value 20. Okay, we added 5 to A and got 20. However, when we see out A now, put it in line here, no, we'll find that A is still 15. A is still 15. That's because we added 5 actually to this, not to this. If you want to add 5 to this, then you have to pass by a reference. So now add 5 ref A. Now, if we see out A in line here, now if we see out A down here, we should get 20 at the very bottom. 20, 15, 20 is what we should get. As you can see, 5 was added to A. That's because we passed by reference instead of by value. When you pass by value, it doesn't change the value here. It only changes the value here. When you pass by reference, it changes the value here and here. Hopefully you understand this. If you create a function, it's automatically, and the parameters are automatically passed by value, unless one of your parameters is an array. Then pass by reference by default. But we haven't dealt with that yet. We haven't dealt with passing arrays. For example, an int array into a function. Maybe I could do an example of that in a future video. But anyway, hopefully you've learned something from this video, and thank you for watching. Hello, and welcome to another video in computer science, C++. We are now going to do a more complicated example. One could say considerably more complicated because it uses new concepts that we haven't done before, and it takes a lot to wrap your head around. This is the bubble sort example, and all it does is it sorts this 1, 2, 5, 4, 3 in the correct order. So when this is sorted correctly, it should be 1, 2, 3, 4, 5. So how do we do that? Well, we have to go and we say, is this larger than this? But we say, the bubble sort works this way. It says, is 1 larger than 2? No, so don't swap it. Is 2 larger than 5? No, so don't swap it. Is 5 larger than 4? Yes, so swap it. And now, is 5 larger than 3? Yes, so swap it. So 5 bubbles up to the top. And then it goes recursively, almost, it goes and does it again. It goes one until the list is, until that doesn't happen anymore, until it goes to the whole list and it's all sorted. Now, how do we swap values in an array? We swap values in an array by using int pointers. Int pointer, we're going to call it x and y. And we're going to have a temporary integer value, x. I'm sorry if this is very complicated to you, but this is how you swap two values generally. You have a temp, you have an xy, and you have a temp. Temp equals x, x equals y, y equals temp. You can forget the pointers for now. X, y, temp equals x, x equals y, y equals temp. That's how you swap two values. But since we're dealing with arrays, we had to use the pointer variables, and you can kind of memorize that. Okay. Now we're going to go to the bottom here and look at bubble sort. This is the complicated part. We have an integer variable I and j. And if you don't understand this whole video, you can skip forward because this is more advanced material. We're going to use something called the STL later, and it's a much easier way to sort values, and it's actually a better way to sort values. The bubble sort is not the best way to sort because it has a big O notation value of n squared, whereas the STL sort function has a better big O notation. If you don't know what big O notation is, you should probably Google that. It has to do with the efficiency of sorting algorithms and other things. But anyway, we have a Boolean value, is it swapped? We have a nested for loop here from I to n minus 1, I plus plus, and a for loop from j to n minus I minus 1. And we increment j. That's just how you go cursively through the list. Okay? Now we look, you kind of have to wrap your head around that. If it's hard to wrap your head around, don't worry about it. Now, look at this part. If array j is greater than array j plus 1, this is what we talked about earlier. Swap the values. And mark the value is swapped to true. Okay? If is swapped isn't false, we keep going. That means something was swapped once, so we're going to keep doing this. Okay? Once it's finally all swapped, and is swapped is false, once is swapped equals to false, we're going to break, and the program is finally sorted. Now, here's the main function. We have an array here, the unsorted list, we print it out using a for loop, which you learned about. It should say 1, 2, 5, 4, 3 in line. Then we sort it with the bubble sort. the array and the size of the array. We output the array sorted. And it should be sorted this time. If we run the program, get array unsorted 1, 2, 5, 4, 3. Array sorted 1, 2, 3, 4, 5. Now, I, as a guide, use geekforgeeks.org/bubblesort. I didn't copy them totally. I had some memory of bubble sort from my C programming class, but C++ is slightly different. And they said you needed to include this, which I didn't know about. So, I'm not sure if you need to include that or not, but you may as well include that just in case. But to me, the hardest part to wrap your head around is this. The fact that you're using pointers and this right here, this number right here. But once you understand that, you understand the whole thing very well. Like I said, if you didn't understand this one, don't worry about it. The more important concept is that you understand what sorting is. There's an unsorted list and a sorted list. If you understand that, good to go. And we're on to the next lectures. Let's deal with classes. A very important topic in C++. Thank you for watching. Hi, and welcome to another video. Today we're going to be talking about classes. Classes are a very important concept in C++ and in computer science because they are one of the cornerstones of computer science encapsulation. When we talked about structs, we talked about modeling an object, such as a person, a thing. Well, let's do an animal this time. Let's create a class. Animal. And the animal will have a public method that returns nothing, called call. It takes no parameters, and couts. This is my call. Line. Well, let's also have some private members. This is a method. This is a function, and these will be members because they are simply variables. Let's have an weight. Weight and let's say and height. Now, in the public part, we also need to have getter, what are called getter and setter functions. This is so that you can set the private variables or the private members within the class. So let's set weight say weight equals WGT. Let's set height, say int HGT, say height equals HGT. Oops, spelled height. All right. Now, we need getter functions as well, so that we can get the information within the main function if we need to. We can't get the weight and height directly from the main function because these are private variables and they can only be accessed within the animal class. We can call the call function within main because it's public. But we need getter and setter functions to get weight and height. So let's get weight return weight and get height return height. Okay. Now I'm going to teach you about something called constructors and destructors. You can construct, you can also set the weight and height initially by constructing the animal object through a constructor. Constructor looks like the following. Animal int WGT int HGT weight equals WGT height equals HGT. This is what's known as a parameterized constructor because it has parameters. We can also create a non-parameterized constructor called a default constructor, where we just have some random values, say 15 and 15 here. Now, for memory management purposes, C++ likes memory management, so you need to create something called a destructor. And all you do is you simply say animal and you put a curly symbol there. That is a destructor. You neaten that up a bit. Okay, fine. Now, Just so we're not making any mistakes, let me see if this program runs fine. Whoops. Okay. We definitely need return types there. So, set them to void. Let's try that again. Whoops. These are not void. These are actually integers. My apologies. Now the program should run perfectly. Run successful. Now let's go into main and create some animals. Animal A. Let's use the non-parameterized constructor. And now let's say cout A dot gives you a list. That's very nice. Get height. And L. We'll do the height followed by the weight. Cout A dot get weight. So we've created an okay. Let's try this. There we go. That's the non-parameterized constructor. Now, that's how you do the non-parameterized constructor. My apologies. Now let's try to create an animal B with the parameterized constructor. Say 30, 12. Copy. Paste. Now it should say 12, 30. It should say 15, 15, 12, 30. $15, $15, $12, $30. So, hopefully this helps you understand what a class is, how to create objects of classes with a non-parameterized constructor, with a parameterized constructor, what a getter function is, what a setter function is, what a constructor is, both parameterized and non-parameterized, and what a destructor is. and both public and private methods and members of classes. Thank you for watching. In the next video, we'll be talking about a slightly more complicated topic, but it will wrap up our class discussion, and it's called polymorphism. Thank you for watching. Hello, and welcome to another topic in computer science. This one is going to be about inheritance and polymorphism. So inheritance is basically where you have a subclass and a superclass. The superclass in this case would be the animal, and the subclass could be, well, such as dog and cat, a type of animal. So we'll make a dog and a cat subclass. They'll have calls that will be meow and bark, for example. So let's create class dog colon public animal and have its call. Okay, now first to do this, we need to have something called a virtual function. This is where polymorphism comes in. Polymorphism is where you can have many different functions of type, methods of different types, such as a regular call, like this is my call, and bark and meow. So, put virtual here. Virtual void call. Okay. Void call. Well, first let's put public void call and its call would be bark in the L. Now we can also create a cat. Create a cat. Copy paste. Cat and say meow. Okay. Now, whoops. I put that inside the animal class. That's not what you're supposed to do. This all is supposed to go underneath. Sorry about that. So, these are new classes. We go outside. Okay. Now what we can do, and this is part of polymorphism, is where you create pointers actually to objects. So let's say animal. Let's create a dog, D, cat, C, create an animal. We can set that equal to Now let's create an animal pointer. Animal pointer, and set it equal to the address of D. Another animal pointer, set it to the address of C. And now, we have to give these names. I'm sorry. Animal 1 and animal 2. Okay. So now, let's say animal 1 dot call. That's the notation. It's actually an arrow. So let's see that out. Let's see out that. See out animal 1 call and line. And let's see out animal 2 call and line. Now we should get bark and meow. Well, we should get these heights and weights, but after that we should get bark and meow. Whoops. Okay, I see where the error is. We don't need to see out the statement. We simply call the function. This is a see out within the function. I'm sorry about that. Now, bark, meow. Now, I'm going to let you review all this code, go through it all, and hopefully you understand it. If you don't, just watch the video again. But this is the basics of polymorphism, classes, inheritance, and everything you need to know about classes, inheritance, and for the most part, polymorphism. There's another thing about polymorphism, and it's called abstract data types. And an abstract data type is simply a virtual void, a virtual class that's set to 0. It's hard to explain, but it's when this is set to 0 instead of filled with anything, and when these has to be strictly set to something when they normally aren't needed to be set to something. But that, for the most part, what I showed you is what you need to know about polymorphism. So, I appreciate your time, and next we'll be learning about the standard template library, and we'll be done with the course. So, thank you for watching. Hello, welcome to the final video in my course, the standard template library. This video will be short and sweet, but it will be very useful to you because it deals with vectors, stacks, and queues. Vectors are similar to arrays. Create a vector, ints. Vector. That's how you do that. Int, call it my. How you add members to your vector is by simply going my vector dot. It should give you options there, but I'm surprised it is not doing that. Push back, push back 15, for example. Okay. Okay, maybe this should probably be lowercase. Okay, there we go. Now let's do another one. My vector push back 16. Now it's working. And finally, my vector push back 17. There's many different ways to iterate through these, but I'm just going to use the simple for loop that we're used to. However, I'm going to show you something interesting. We can do this. Int I equals 0. I is less than my vector dot size. That way it automatically knows the size of the vector. You don't have to type in 3 or anything like that. Now let's simply cout my vector at I in line. And let's run the program. Should get 15, 16, 17. 15, 16, 17. Okay. This is basically all you need to know about vectors. They're very similar to arrays, and you can add by using pushback. You can iterate through them using the at. And you can use the size in order to iterate through a vector of unknown size, which is interesting. Okay, now let's create something called a stack. A stack is a first in, first out data structure. It's created like this: stack int my stack. Okay, how we do my stack push let's do 0. My stack push push 0. Sorry, 1. And let's just copy paste. I stack that push 2. Now, iterate it the same way for I 0 I and set my stack size plus out actually, let's just do this. See out my stack dot top to give us the top value, which in a stack is similar to those trays you get at a restaurant. So it's the first in and first out. So you're stacking the first one in was, I'm sorry, I made a mistake. Stacks are last in, first out. So stacks are last in, first out. Queues are first in, first out. Please don't get those confused. Stacks are last in, first out. Queues are first in, first out. So hopefully that doesn't confuse you now that I made that mistake, but stacks are definitely last in, first out. So last one in, first one out. The last one in was 2. So the first one out will be 2. So we should get 2. 2. Now if we do my stack pop, do a cout statement, should get let's see what we'll get here. We'll get 2 and should get 1, I believe. Unless my math is wrong. 2, 1. Should put an end line there. Let's do that so you can better understand it. Okay, so we get 2, 1. Okay. Now let's talk about queues. Queues are similar, except for they're first in, first out. Just like a line. You're the first one in, you're the first one out. So, let's create a queue. Queue. Int. My queue. My my queue push for example. Do 15 through 17 again. Copy. Paste. 16, 17. Now, 15 was first this time. So that means who's at the front? IQ front person at the front is 15, because it's just like a line. Okay. Now, if we do this, my UE up. What do you expect that? Whoops. We don't put it there. Sorry about that. We don't put it there. We put it here. If we put pop here, we'll get a different result for cout. Well, who gets to leave first? 15 gets to leave first because he was at the head of the line. So the front will be 16 now. 16. As you can see, we got 16. I hope you've learned something from all of this, and I hope you've learned something from this course. My name is Sean, and I've enjoyed creating this course, and I hope you've enjoyed learning from this course. Thank you so much for watching. Feel free to comment or message me anytime if you have any questions, and thank you again. Bye-bye. Hello. Welcome to another educational video on computer science. I'm Sean, and today we'll be talking about linked lists. Linked lists are something you can use to create something called data structures in C++, such as if you want to create a stack, a queue, a list, or a linked list, obviously. But I'm actually going to use Microsoft Paint first to illustrate what a linked list is really. It's a series of nodes. So a node can be looked at as a box with two sides. One will have data, and one will have a pointer. Okay, so you can say store 1 here, and the next one will have a pointer to, say, another node. This will point to the next node, for example. Now you have a list of two numbers. This is a linked list with data of 1 and 2, and they're linked via the pointers. So I'm going to show you what this looks like in C++. First, you create a class called node. Public int. And we make our data block. I showed you. And we make our pointer block. What kind of pointer? Well, it's a node pointer. It's going to be a pointer to another node. Okay, so how do you actually create nodes in the actual program? Well, very simple. You go to the main function and simply do something like this. Node pointer. We can call this first. We set it equal to null initially. Call this one node pointer second equals null initially. Node pointer third equals null initially. So we've created the node pointers block. Now we need to create the nodes themselves. So let's do this. First equals new node. Second equals new node. Third equals new node. Okay. So now, how do we connect these? Well, first let's store some data in these. Let's say first, now we do the dash symbol, dash data, hit the tab, equal to, let's say, start from 0. Because we know in computer science we like to start from 0. First, second data equals 1, third data equals 2. Okay. Now we have the data in each node. Now let's connect to each node. Let's say first next first should give us, yeah, okay, next. We want that to equal second. Okay, so we've just connected first to second. So we've just basically said, let's connect this to here. Is what we just did. Okay. Now let's do second next equals third. And let's do third next equal to null. So the last pointer in the list will simply point to nothing, just like 2 in this example, except in our example it is 3. So it points to nothing, null. Okay. So what I've used is geeksforgeeks.org has created a way to print out. I'm not plagiarizing anyway, but I had forgotten how to print this out, and they reminded me. So this is how you print out I'm giving credit to geeksforgeeks.org/linked-list-set-1-introduction I'm giving credit to them for this, but this isn't plagiarizing. I just think that they give a good way to print out linked lists, and it's universally taught, so it's not like plagiarism. Everybody knows how to do this, really. So void print, you can call it anything you want. Print node. We want to print a node. Let's call it the first one. Okay. And we're going to say while. Actually, sorry, not first one. While node. Let's just call it node. While node does not equal to null, we're going to output the data. Oops. Sorry about that. Node. Oops. They use n as their example. I'm using data. I'm using node instead of n to be more clear. So node, and we can put a space here, or an end line, or anything we want. So that's how we'll print out node equals node next. Okay. What this does is, this says while the current node pointer is not equal to null, say the data. Okay. Then set the current node pointer to the next node pointer. Okay. Now we can go here. The program should output, if we use the print function, print first. The program should simply output 0, 1, 2. 0, 1, 2, as you can see. I hope you've learned something from this video. I know linked lists are a little more complicated than some other topics in C++, but they can be used to create all kinds of things like stacks, queues, vectors probably. In my computer science course, we created something called a quack, which was a combination of a stack and a queue together using a linked list. So we had to do that using a linked list. So maybe you'll have that as an assignment in your computer science course. So think about how to do that. Maybe as a side project, think about how to create a quack with your linked list here. I know I didn't show you how to insert and delete. That will be saved for another video. I didn't show you how to insert and delete into a linked list, which is very important. So that will be in a future video. This is just the basics of creating a linked list. So thank you for watching.